Welcome to Week 4, Confidence Intervals Example. This segment will focus on an example of calculating a measure of risk and the associated 95% confidence intervals. Many of the world's used electronics, such as cell phones, TVs, and computers, get shipped to cities in China for recycling. Both children and adults work to separate out rare metals in the electronic devices. Some of the children have very high metal exposures to lead and cadmium. Our example is adapted from a study by Yang et al. And published in 2013 entitled Effects of Lead and Cadmium Exposure from Electronic Waste on Child Physical Growth. In our fictitious example, we will look at a cohort of children in Guyu, China, who recycle metal in electronics. This is a diagram of the cohort study. We start with a cohort of children ages 5 years old who are working on recycling electronics. With an N equal to 1,725. Then we measure the concentrations of the metals in their blood at baseline. Based on their blood concentrations of metals, we then classify them into children with high metal concentrations in their blood, where their N equals 589, and low metal concentrations, where the number is 1,136. We then follow both groups of children over 10 years and measure their physical growth, measured by shorter height, at age 15. This is how you would then set up a 2x2 table to calculate the risk of decreased growth or shorter height in children with high levels of metal concentrations in their blood compared to children with low-level concentrations of metals in their blood at baseline. Now, I would like you to calculate the risk ratio of decreased growth or shorter height, potentially related to heavy metal exposure. The answer is 0.139219 divided by 0.025528, which is equal to 5.45. The interpretation of this risk ratio is children with high metal exposures at age 5 were 5.45 times as likely to have decreased physical growth or shorter height over a 10-year period compared with children with low metal exposure. Now, how do you calculate the 95% confidence intervals associated with this risk ratio? One possibility is with this free software, and you could either use OpenEpi or EpiSheet, and the two links are provided here. So using the free software, we plug in the numbers to our 2x2 table and calculate the 95% confidence interval. In this example, for the risk ratio of 5.45, the 95% confidence interval is 3.614 to 8.23. Is this risk ratio estimate statistically significant? What do you think? The answer is yes. This risk ratio is statistically significant because the 95% confidence interval does not include the null value of 1.